After we have worked out with factor theorem and remainder theorem to figure out whether an integer is a zero of a polynomial or not, it is quite essential to look at a rational zero theorem. So we will confine ourselves to the coefficients of the polynomial. So let us consider a polynomial fx of degree n, okay, where an is the leading coefficient and a0 is the constant term. Then the rational zeros of this polynomial will be of the form p over q, where p is the factors of a0 divided by q is the factors of an. So consider a polynomial f of x equals to 2x cubed plus x squared minus 4x plus 1. So let us first figure out the rational zeros of this polynomial. So p would be the factors of constant 1, so that would be just simply plus minus 1, and q would be factors of 2, which is plus minus 1 and plus minus 2. So then the possible values for p by q would be, p divided by q would be, possible values would be plus minus 1, 1 divided by 1 will give us 1, and plus minus you can change the sign, and similarly 1 divided by 2 would be plus minus 1 over 2. Which of these four numbers are rational zeros of this polynomial? So for this we would use the factor theorem. Okay, so we will simply plug in these values, all of these four values in this polynomial, and try to see whether the remainder is 0 or not. Okay, if the remainder is 0, it's a 0 of the polynomial. If not, not a 0 of the polynomial. So here let us start from f of negative 1. So f of negative 1 would be simply 2 times negative 1 whole cube is negative 2 simply, plus this is negative 1 square is plus 1, minus minus plus 4, okay, since x is negative 1, so that would make it plus 1. So that is, so since f of negative 1 gives us a non-zero number, so this is not a 0. Okay, so x equals to negative 1 is not a 0 of this polynomial. Let's go for f of 1. So that is 2 times 1 cube is 2, plus 1 square is just 1, minus 4 plus 1, okay, equals 2 plus 1 is 3, plus 1 4, minus 4 is 0. So this is a 0. That means x equals to 1 is a 0 of this polynomial. Similarly, let us check for other numbers, f of negative 1/2. So f of negative 1/2 will give us 2x cubed means 2 times negative 1 over 8 plus 1/4, okay, 1 by 2 square is 1/4, minus minus plus 4 divided by 2 plus 1. Then you can see that 2 times 1 is 2, 2 times 4 is 2 times 4 is 8. So that is negative 1 by 4 plus 1 by 4 plus 2 plus 1. So this thing cancels out, so this would be 3, which is also non-zero. So this is also not a 0. Okay, so that means x equals to negative 1/2 is not a 0 of this polynomial. Similarly, let's go for f of 1/2. That would be 2 times 1/8 plus 1/4 minus 4 by 2 plus 1, which is also 1/4 plus 1/4 minus 2 plus 1. So that is 1/2 plus 1, that's 3 by 2, minus 4 would be negative 1/2. Okay, so this is also not a 0. That means x equals to 1 by 2 is not a 0. So the only rational 0 that we got is x equals to 1. So we can write that among those four numbers, x equals to 1 is a 0 of f of x, or you can also write x minus 1 is a factor of f of x. Okay. Now let us try to figure out all the zeros of this polynomial. Now since the degree of this polynomial is 3 and we have gotten 1 0 of the polynomial, so rest of the 2 zeros would be either irrational numbers or complex numbers. Okay, let's figure that out. Since we have already known that x equals to 1 is a 0 of f of x, so let's go for synthetic division, which will allow us to figure out the quotient. Okay, so this is 1 and 2 comes here. The coefficient of x square is 1, coefficient of x is -4, and 1 is the constant term. So let's finish the calculation. 2 comes down, 1 times 2 is 2, so 2 plus 1 is 3. Then 1 times 3 is 3. -4 plus 3 is -1. 1 times 1 is -1. 1 times -1 is -1. So this is 0. So the last number is remainder. So remainder is 0. So the quotient would be q of x is 2. This is the leading term. And highest power of the original function or original polynomial was 3. So its power would be 2. Okay, power should be reduced by 1. Plus this is 3x minus 1. So once we have gotten this quadratic polynomial, which is the quotient of this division, then we can easily figure out the zeros of this polynomial. Okay, by let us use quadratic formula. Okay, which is simply this is a equals to 2, b equals to 3, and c equals to -1. So then x equals to minus b is 3 plus minus root under b square is 9 minus 4, a is 2, and c is -1 by 2a. So x equals to -3 plus minus root under 9 negative positive, and 4 to 8. 9 plus 8 is 17 by 4. Okay, so x equals to -3 plus minus root under 17 is our, so that can be written as x equals to -3 plus root under 17 by 4 as 1, and another to be x equals to -3 minus root 17 by 4 is our 2 zeros. Okay, so there are 3 zeros: x equals to 1, x equals to -3 plus root 17 by 4, and x equals to -3 minus root 17 by 4. So these 3 are the zeros of this polynomial. Now let's do another problem example. You can find all the zeros of this polynomial, this particular special polynomial, by other means also, but here we will stick to rational theorem and factor theorem at first. So here p is the factors of this number -1, which is simply plus minus 1, and q is the factors of this coefficient, the leading coefficient, which is plus minus 1. Thus p by q, that means the rational zeros of this polynomial will be of the form p by q, which is simply plus minus 1, since 1 divided by 1 is just simply 1, and we just need to change the sign. Okay, now let us see which of these two numbers are the is the zero of this polynomial. So f of 1 is simply 1 cube minus 1, which is 0. So this is a 0. Okay, f of x equals to 1 is a 0. F of -1, let's check for this also. -1 whole cube minus 1 will give us -2, which is not a 0. So x equals to 1 is a zero of the rational zero of this polynomial. Now let us go for synthetic division. Let us go for synthetic division, which is simply 1, and the leading coefficient is 1, so that's fine. X square is missing, so this is 0. X is also missing, 0, and this is -1, so we have this. Since we did this thing, since this is a cubic function, so we must have expressions involving x square and x. So that's why we did this. Then 1 comes down, so 1 times 1 is 1. Okay, 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. So -1, +1 will give us 0. So this is the remainder. And the quotient is x square. Okay, since highest power of the polynomial is cube, so we must reduce the power by 1, plus this is x plus this is 1. Then after we have gotten this, then let us use the quadratic formula, which is simply x equals to negative b means negative 1 in this case, since b equals to 1, plus minus root under b square is 1 minus 4ac. 4 a is 1, c is also 1, so 1 minus 4 divided by 2. So that will give us simply it will give us negative 1 plus minus root under negative 3 by 2. Therefore, I can write x equals to negative 1 plus minus root under 3i, since I is root under negative 1. Or you can think that this is I square equals to negative 1. That's the imaginary relation. So we can see that this polynomial has 3 zeros. One is x equals to 1, and next two are complex numbers, which are negative 1 plus root 3i by 2 and negative 1 minus root 3i over 2. So those are our zeros.